everyone, myself Dr. Vinayak, working as Assistant Professor from the Department of Agriculture Engineering, Aditya University. Up to last class, we have seen the combine harvester and classifications of the combine harvester. Different factors need to consider before operating of the combine harvester. Today's class, we can discuss the different terminologies related to combine losses. These are the learning outcomes of the today's class. Define the combine harvesting losses and factor affecting of the losses. So here the combine losses was divided into the 4 sections: header loss, threshing loss, separation loss and cleaning loss. So in the header loss, this part we can cause of the header loss. Both reel speed and cutter bar will consider as a reel RS and cutter bar. Here header losses will be carried out. Threshing losses will be considered at threshing chamber. This one is a threshing chamber. And separation losses will be carried out here at the component of the sieves. We can consider as a separation losses, and cleaning losses where the blower was located. At that situation, we can consider as the cleaning losses. Let us move on to the next slide. So in detail, we can discuss the header losses and threshing, separation, cleaning losses. So header losses can subdivide into the lodging losses, shutter losses and cutter bar losses. So here lodging losses or shutter losses, cutter bar losses are nothing but, so here one crop material was is present in the field. This one is a crop material. So up to now we have seen the components of the cutter bar. This one is a reel, this one is a crop, this one is a cutter bar. So here lodging loss is nothing but this reel was need to guide this crop material towards the cutter bar. So if cannot guide this reel bar towards the cutter bar, that will cause of the lodging losses. Next one is the shutter loss. This reel need to operate optimum speed. Okay, if increase the speed of this reel, what will be happen due to the overspeed of this thing? So whatever the grain present over this plant material, it will be fall on the ground surface due to the high speed of the reel. So that is comes under shutter loss. Coming to the cutter bar loss, some of the crop material does not harvested by the cutter bar. So it may be worn out of the knife section, it may be some other reasons will be there. So that is comes under cutter bar losses. Let us move on to the threshing losses. So threshing nothing but separation of grain from the chaff material. No. So some of the crop material does not threshed by the threshing chamber. So it will be cause of the loss of the threshing. Okay. Threshing or cylinder losses are those unthreshed grain head that escape from the combine at the straw material. It is expressed as the percentage of total grain enter into the machine. Some of the grain material, unthreshed grain will be passes throughout the straw material. So that is considered as a threshing losses. Okay, so it may be last class we have discussed the even threshing efficiency also. Some formulas also we have discussed. So that is comes under threshing losses. Okay, coming to the next slide, important parameters need to there regarding the header losses. Some factor will be effect on the header losses. So cutting height. Okay, if the suppose I will take the one plant material here, this one is a reel. So this one is a cutter bar. Cutting height. If the cutter bar height was located 8 to 10 centimeter from the ground surface, this one is a GS, ground surface, this cutter bar was located from 8 to 10 centimeter. So some of the crops, they can provide the crop availability of plant material will be there below the 8 surface also. Some of the green gram you can take, grain will be located below the 8 centimeter. In that situations may be cause of the loss of the grain. So here the cutting height was very important while harvesting the crop. Based on the availability of the grain in the plant material, you need to harvest the crop. Next one is a reel position with respect to the cutter bar. So the main function of the reel is guide the crop towards the cutter bar. So during the process of rotation of this reel, some spokes will be there throughout the periphery of the reels. These spokes was guide this crop material towards the cutter bar, right? So the position of this reel was very important. It may be 30 centimeter ahead from the cutter bar, otherwise 40 centimeter ahead from the cutter bar. Based on the adjustment, based on the crop material, so the reel position will be changes. Okay. So first one is the cutting height, next one is the reel position with respect to the cutter bar, and reel speed with respect to the forward speed. So here one small formula is there, reel index equal to VR by VC. VR nothing but tangential speed of the reel, VEC nothing but forward speed of the combine harvester. Based on the forward speed of the combine harvester, the reel speed should be in this manner. Okay, should be respect the forward speed with respect to the reel speed. The peripheral speed of the reel should be 25 to 50% faster than the forward speed of the combine harvester. If the forward speed of the combine harvester is 2 km per hour, so it should be more than, the real speed should be 2 into 50%. So here the forward speed of the combine harvester, suppose we can take the 2 km per hour. So whereas the real speed is more than 25 to 50%. So 2 into 50%, whatever the will get the answer, that speed should be maintained in reals. This one is a reel, right? So coming to the operation, the reel should be between 1.25 to 1.5. Operation of the reel speed index, it will be called as a reel index or reel speed index we can call. It is should be range 1.25 to 1.5. So let us move on to the next slide. Separation losses. The separation losses also called as the Walker losses. So here we have separate the grain material from the chaff material. Okay, here set of sieves was presented in walkers. So based on the size of this grain, we can separate the grain from the chaff material. In conventional combines, lost grain with the straw expressed with as the percentage of total grain enter into the combine. Okay, so whatever the amount of total grain enter into the combine, that grain should be come through the outlet of the grain elevator. So otherwise it may be cause of the loss. So either that loss will be occurred at a threshing chamber, that loss will be occurred at separation chamber, that may be occurred in cleaning chamber, wherever it may be. Okay, we need to calculate all losses from this combine harvester. We need to calculate the threshing efficiency or grain input efficiency. Next one is the cleaning losses. Cleaning loss also called as the shoe losses. So some of the chaff material, by using the blower, we can separate the grain from the chaff material. That is comes under cleaning losses or shoe losses. The grain lost with the chaff expressed in the percentage of the total grain enter into the combine harvester. So here we have seen the different losses. First one is the header losses and threshing losses, separation losses and cleaning losses. So header losses will be occurred at front side of the combine, threshing losses will be occurred at threshing chamber, separation losses will occur at sieves, cleaning losses will occur at blower section. So this cleaning loss is also called as a shoe losses. This separation loss is also called as a walker losses, right? We need to remember here. So this one is some graphical representation of the losses. So here embossing nothing but material over the grain to indicate the kg per minute and grain losses. Simply go through it. Next one is a summary of the today's lecture. We have seen the different losses in combine harvester, some of the factor effect of the losses. So like height of the cut and the reel speed and the forward speed of the combine. These are the different factors, and moisture content of the crop. So these are the different factors effect on the combine losses. Thank you.